Hey there, my name is Richard Stillman. I'm with Doane University. This is my Chemistry 2 Section 1 class experiment. It's called the iodine clock reaction experiment. My professor is Dr. Ken Capps. These are some of the materials I'll be starting with for my lab. I got hydrogen peroxide 3% here, which I have poured off 150 milliliters. I have my cornstarch here. I needed 0.4 grams, which I measured on a little scale. What I did is I got my solutions going so that the experiment would move on a little quicker. I used a povidone iodine solution. It has 1% available iodine. So I had to adjust my numbers. I ended up coming up with 120 milliliters of iodine solution. I have my vitamin C tablets. They're 100 milligrams. I used 2 of them for 2,000 milligrams. I got that into a solution. It did have to drain through a funnel to kind of clear up the solution. It had a lot of insoluble gelatin capsule parts in it. I also did, for my solution B, I got my cornstarch mixed up with my distilled water, and I had to heat it to a boil so it would become a little bit clearer, not as cloudy. All right, so we're going to try to mix these together, these solutions A and B, and see if we get a reaction. Oh, some of the other materials I had, I took my temperature with my handy-dandy thermometer here, stirring stick. Here's my clock. It's a stopwatch. All right, let's get this out of the way here. So since we had this going, this is my vitamin C solution. We're going to go ahead and pour this iodine in here. And what we're hoping to see is the iodine will at first change the color of the solution, but then it's going to change back because the vitamin C is going to counteract it. All right, let's get you a little to where you can see here. Let's go back here. All right. Look at that change. All right. Let's get a little stir here. So I can see it's gradually getting back clearer. It did do an initial color change, but it was still undergoing some color change here. Okay. So we have that. That's going to be our solution A, which I needed to explain here that the 1% solution, the 120 milliliters of iodine, it was reacting with the 2,000 milligrams of vitamin C, and it basically converted that iodine solution into iodide, which is an it's an iodide ion, an I minus. All right, so that was going on there. So we have our boiling cornstarch and distilled water solution that was boiled. I'm going to have to top that off with my 150 milliliters of hydrogen peroxide. Okay. Just going to wipe off my stirring stick here so we don't get cross-contamination. So we have like 500 milliliters of solution here. We're going to pour that into our solution B, which I have labeled. I don't know if you can see that. Ooh, it's hot. Okay. Here's our solution B. Solution A. Pour that in here. And then we're going to top that off with my distilled water. Now, we just take, this is going to be our mixed solutions together, and I just want to do equal parts. And we're going to time it. So I have my stopwatch here. So first we'll do our solution A. We're going to fill it up to 250 milliliters. So let me make sure I got the right mLs. Okay. Here's my 250. All right, this is where we start the clock. Here we go. I'm going to go up to 500. Now I heated it to basically expedite the color change. Talk a little bit what's going on here while we wait for the color change. We have basically our iodine. Oh, there we go. There's a color change. Might take a little bit to darken up here. Basically what's happening is our iodine solution, when it met with our vitamin C, it broke it down into, converted it into an I minus. Then in our other solution, we basically, when we combined all of these, we had our hydrogen peroxide was working with our two I negative ions. That was mixing with our ascorbic acid, two hydrogen ions. And then it got converted. It was basically both chemicals were kind of counteracting what it wanted to do there. And it ended up converting it back into iodine and two water molecules, H2O. So essentially the I negative was converted back to the iodine, I2. And when the vitamin C ran out, what it did is it converted the iodine and the I negative into a triiodide. That met the starch and ultimately created a blue iodine starch complex. Now, these were some of the factors. I forgot to tell you, it took about a minute for that change to take place. The factors affecting reaction time, concentration of the reactants. So I try to use equal parts, but if we were to have a higher concentration of I negative or more hydrogen peroxide, it would have been quicker reaction. If we had more higher concentration of vitamin C, it would have taken longer. Also, conversely, working with the temperature of the solution would be quicker, and if the temperature was increased, it would be quicker. If the temperature was decreased, it would take longer. All right. I also broke down the equations here. I don't know if you want to look here. You can kind of see, I wrote out the equations, kind of what's happening. All right. And I also just want to close this out here with my reference. This is what helped me do the experiment. It's now red. This was his iodine clock reaction experiment. I did my best to simulate it. And thank you for watching my experiment.